Hello friends, good evening. Hello friends, good evening. Is it audio video clear? Good evening friends. Audio video clear? Good evening friends. Okay, some technical issue. Whatever I am writing here, it is not showing. Please wait 1 minute. I will resolve that. Audio video clear? Some technical issue. Whatever I am writing here, it is not showing. Please wait 1 minute. I will resolve that. Audio video clear? Yes. Okay. Good evening, friends. Hello, friends. Good evening. Uh, Today we will discuss. Yesterday, we in last two sessions we already saw some very important area from DBMS. How to find the primary key, how to find the candidate keys. I already explained, and canonical cover also I explained in the previous two sessions. Yesterday we saw what is functional dependency. Okay, what is functional dependency set and what is equivalence of functional dependency. Okay, wait a minute, my photo is not visible now. Yes, now my photo is also visible, right? Okay, thank you. If you are preparing for UGC net, these lessons are very helpful because after clearing my concept, I am here to explain those who are preparing for the UGC net. Okay, this is free of cost. You can refer your friends also if anyone is preparing for the UGC net. Okay, I will teach whatever the important topics, most important topics from the um, UGC net computer science, friends. Okay, thank you for watching. Please subscribe and please share with your friends those who are preparing for the UGC net. Okay, now today we will see what is normalization and some important some gate previous questions also we will solve. Okay, this is it is the process of elimination of redundancy of anomalies like insertion, deletion and modification. Okay, normalization means we will delete the redundancy of data while inserting or while deleting or while modification of relations. We already saw in the database we will store the data in the form of relations, right? Okay, if any redundant data is there, it is every time we have to suppose every time there is a need of deleting the same data in so many places and inserting the same data in so many relations. Okay, that's why we need normalization to maintain data in a, okay, to eliminate the redundancy. Okay, sorry, what are the different types of normal forms are there? We will see. One is first normal form, second normal form, third normal form. This is boys code normal form. 4NF, 5NF is also there. When for our exam, up to this BCNF is enough. Okay. When a relation is in 2NF, that means it is 1NF. Okay, this is the diagram, friends. If a relation is BCNF, yeah. If a relation is in 1NF, it is in 2NF also. If a relation is in 2NF, it is there, it will be in 3NF. Okay, if a relation is in 3NF, it is in BCNF also. But reverse is not possible. Okay, if a relation is in 1NF, it may not be 2NF. If a relation is in 2NF, it may or may not be in 3NF. Okay, we have to find. If a relation is in 3NF, okay, it is in 2NF and 1NF. In reverse, it may not be possible. Okay, it may not be in BCNF, friends. Okay, now we will see what is 1NF, what is 2NF, and what is 3NF. How to find from the given relation, is it relation is 1NF or 2NF or 3NF, we will see now. Okay, this is 1NF. A table is said to be in 1NF if every attribute should contain atomic values only. Multi-value attributes are not allowed. We already saw what are multi-valued attributes. Suppose address is there, right? Address is having more than one value. Okay, it is city, suppose state, country, like this. In one attribute, we should not have more than one value. That is called as multi-values. Composite, composite also not allowed. Suppose if a person is having more than one phone numbers, right? If a phone number column is there, okay, one person may have more than one phone number. Yes, that that we cannot write in single cell. Okay, that is called as first normal form. We have to delete one phone number and we have to make separate column for the phone, for each phone number. That is called as 1NF. Multi values are not allowed. Composite attributes are also not allowed in 1NF. Here we will see with one example. Here this is a student table. Student ID, student name and subjects are there here. This is the these are the student IDs. These are the names of students. Here see in the subjects place we saw English, comma maths, English, physics, maths. This is not allowed in 1NF. In single cell, it should maintain only one subject, right? We already saw in ER relations this type of composite attributes we have to maintain separate table. That means student ID and subject. We have to maintain separate table if there is multi values in a relation. But we should not write in the single cell, two names are not allowed. That is the 1NF. Suppose this is student number 101 and English. Student number 101 is subject maths also. Again, student number 102 English. Student number 102 physics. Like this, we have to maintain a separate table for the multi-valued attributes. We should not write the more than one value in a single cell. It is not allowed in 1NF. That means if it is not allowed in 1NF, then it is not allowed in 2NF also. It is not allowed in 3NF also, right? This is the 1NF. Okay, now what are prime and non-prime attributes? So, okay, we will see what is prime and not non-prime attribute. I will explain with one example. Suppose A, B, C, D is a relation. A to B, B to C, and C to D are these are the functional dependencies given in the given relation. Tell me how to find the candidate keys. I told one trick to find candidate keys. First of all, whenever we are finding candidate keys or primary keys, we have to see the right hand side of the functional dependencies. What is not there, whichever the attribute present in the relation but not present in the right hand side, that will compulsory, that will come under primary key or candidate key. Okay, here B is there, C is there, D is also present here, but which is not present here? Right hand side A is not present. That means the candidate key, in the candidate key A must be present. Okay, now what we will do? We have to take the closure of the whichever the attribute is not present in right hand side. What is the closure of A? In closure of A will come. From A we can determine B, from B we can determine C, from C we can determine D. Okay, in this relation A is the candidate key. A is the candidate key. In this relation A is the candidate key. We have to check, is there any other choice of candidate keys? How to check? If the current candidate key is there any right hand side of any other functional dependency? Is A there in the right hand side of any other functional dependency? No. In any functional dependency, in first also right hand side A is not there. In second functional dependency also right hand side A is not present. In third functional dependency also in right hand side A is not there. That means only A is the candidate key in this relation. Except A, we cannot get all the attributes of the relation from any other attribute. Okay, now we will try to find the B closure. Are we getting all the attributes of the relation or not? We will see. From B closure we will get B. From B we are determining C. From C we can determine D, right? But except B, C, D we are not getting anything. We are not getting attribute A from the B closure. That means B cannot be candidate key. It is not a candidate key. We can try with C also. C closure, from C closure what we are getting? C closure, C we will get, and from C we can determine D. Only C and D we are getting from the C closure. That means C also not a candidate key. Only A is the candidate key for this relation. That means what is prime attribute and what are non-prime attributes. Okay, prime attributes means part of candidate keys. Part of candidate keys. Non-prime attributes. What are non-prime attributes? Whichever the attributes are not present in the candidate key are those are called as non-prime attributes. In this relation, what are the non-prime attributes? B, C, D are the non-prime attributes in this relation. Okay, friends, before going to second normal form, we should have a clear idea what are the prime attributes and what are the non-prime attributes. Okay, I hope you understand what are prime attributes and what are non-prime attributes. Prime attributes means those attributes which are the part of candidate keys. In this relation, only A is the candidate key. That's why A is the prime attribute. Okay, B, C, D are the non-prime attributes. If an here we will read now we will read the definition here. If an attribute is a part of any one of candidate key, then it is a prime attribute, else non-prime attributes. With this example, I hope you clear the prime and non-prime attributes. Now we will see what is second normal form. That means I already told if a relation is in second normal form means it will be compulsory in 1NF because 1NF is there inside, right? That's why if a relation is in 1NF, it should be it will be in 1NF. Independent of partial dependency, there should not be any partial dependency in the second normal form. What is partial dependency? Partial dependency means second normal form is a fully functional dependent on candidate key. If a relation is said to be in second normal form, first rule. Suppose we will take the same example, previous example, A, B, C, D. A to B functional dependency is there, B to C is there, and C to D functional dependencies are there in that relation. The first rule for second normal form is it should be fully functional dependent on candidate key. Fully functionally dependent on candidate key. That means left hand side should be candidate key. Okay. This is the first rule. We have to remember this is the first one in the second normal form. Left hand side should be candidate key. When now we will read this point. When a non-prime attribute instead of depending on complete candidate key is dependent on part of candidate key. That means if in this relation we already found only A is the candidate key. A is the candidate key. Now it is okay. But if a functional dependency is like this, suppose this example is not correct for the second normal form. I will give examples first. For now, please understand the rules of second normal form. We will solve gate previous year's question also. Okay, first rule is left hand side should be candidate key. Right hand side may be prime or non-prime. There is no problem. If the partial dependency is not allowed in second normal form. Partial dependency means prime to non-prime is not allowed. This is called the partial dependency. If instead of depending on a non-prime attribute, instead of the, please try to understand this definition, a non-prime attribute instead of depending on complete candidate key is depending on part of candidate key. Actually, it should be like this: candidate key to non-prime or prime, no problem. Now prime is anyway it is right, but candidate key to non-prime is allowed in second normal form. That should be fully functional dependent on candidate key. That means left hand side should be candidate key. But if it is if this non-prime attribute is depending on prime attribute, this is not allowed in second normal form. That means you have to remember that what is partial dependency? Partial dependency means part of candidate key should not determine non-prime attribute. This is the partial dependency. Prime to non-prime, that is not allowed. That is called as partial dependency. Okay, friends, please tell me, is it clear? What is partial dependency is clear to you? What is partial dependency is clear. I hope you are clear with it. Partial dependency means actually second normal form is fully functional dependence on candidate key. If left hand side the non-prime attribute, especially the non-prime attribute should be fully functional dependent on candidate key. If instead of candidate key, if prime is came in left side and right side non-prime is there, this is called as partial dependency. This partial dependency is not allowed in 2NF. This is the second rule you have to remember. Next, third one is non-prime to non-prime is allowed in second normal form. There is no problem. Prime to non-prime is not allowed, but non-prime to non-prime is allowed in second normal form. Okay. Uh, right hand side prime is also, there is no problem in second normal form. If left hand side prime and right hand side prime, this is also, there is no problem in second normal form. Okay, now we will do the revision of second normal form. The second normal form is fully functional dependent on candidate key. If partial dependency is not allowed, I asked. Okay, okay, friends. This prime to non-prime, prime to non-prime is not allowed in. This is called as, this is not allowed in second normal form. Non-prime to non-prime is allowed. There is no problem, and prime to prime is also allowed. Okay, friends. Now we will go for what is third normal form. This is the definition of partial dependency. When a non-prime attribute, instead of depending on entire candidate key, is depending on part of candidate key. That is called as, you have to remember this type of written definitions also, friends. Nowadays questions are coming on definition base. Okay, maybe they will give what the definition of partial dependency is. They will give 1, 2, 3, 4 answers. From that we have to select which is the definition of partial dependency. Okay, uh, here A to B is a partial dependency if and only if A is a subset of candidate key and B is non-prime. That is, here it is saying that this is a prime attribute and B is a non-prime, then it is a partial dependency. For partial dependency, incomplete candidate key, that is subset of candidate key, should not determine non-prime attributes. But subset of candidate key or incomplete candidate key can determine prime attributes. Okay, I told right, prime to prime is not allowed. Prime means this is a subset of candidate key. This is also a subset of candidate key. This is allowed in second normal form. We will see one example here. He has given R relation A, B, C, D, E is given. Functional dependencies are BC to D, AC to BE, B to E. Here the question is, check whether it is in second 2NF or not. This is the question. We have to check, is this relation is there in 2NF or not. What we have to do to find the relation is in 1NF, 2NF or not? First of all, we have to find the candidate keys, because how can we know which are prime attributes, which are non-prime attributes? Only if we find the candidate set of candidate keys, from that only we can uh, find which are prime attributes and which are non-prime attributes and which are candidate keys. Then only we can say this relation is in 2NF or not. For that, okay, before finding the candidate key, what we have to see first from the given functional dependency, we have to see the check the right hand side of the given functional dependencies. Always you should write the functional dependencies in vertical like this. Don't write the given functional dependencies in horizontally, because we cannot observe the functional dependencies properly. That's why always write the given functional dependencies in the one by one like this. And first you have to check for the right hand side. What from the, in the right hand side we have to check whichever which are not there from the given relation, which attributes are not present in the right hand side from the given relation. Here D is there and E is there, B is there, E yes, D, E, B. Okay, A, C is not there in the right hand side. That means what is the meaning of that? In the candidate key in RHS, A comma A C is not present. That means in candidate key AC must be there. AC must be there. Don't forget this. For that, first of all, whatever is not there, we have to try with that, because anytime candidate key should be minimum, right? If we don't get in the AC closer, then we have to add with some other attribute and we have to take the closer. Initially, whatever is not there, from that we have to try if it is there in the left hand side. Okay friends, now what is the closure of AC? From AC closure we will get AC, and from AC we are getting AC is determining BE, B is determining E. From BC we can determine D. A, B, C, D, E. All the attributes from the relation we are getting from the AC closure. That means we can say that AC is the candidate key, right? AC is the candidate key. Okay friends, now AC is the candidate key. How to find, is there any other candidate keys for this relation? For that we have to see, please please try to understand, if AC is there any right hand side of any relation, any functional dependency here? No, AC is not there in the right hand side of any of the given functional dependencies. Then that is meaning is there is no other candidate keys, only AC is the candidate key of this relation. If suppose AC A or C is present in right hand side of AC, is complete AC is present any right hand side of this relation, then we have to check the closure of that left side. Then if we will get the complete attribute set, then that also become candidate key. We will see that type of question also. Now don't worry about that. Now what is the here we came to know AC is the candidate key. Now we have our task here is we have to find whether the given relation is in 2NF or not. Okay, here AC is the candidate key. That means what are the prime attributes? What are non-prime attributes? Please tell me. Two members are there in online. Please tell me. Don't be silent, please. What are prime attributes and what are non-prime attributes? Tell me, please. I already told what are prime attributes and what are non-prime attributes in the previous slide. From here, I told the we found here AC is the candidate key, right? Then what are prime attributes? Please give me response. Okay. Part of candidate keys are prime attributes, right? A, C are the prime attributes here. What are non-prime attributes? Whichever are not from the given relation, what are the all attributes A, B, C, D, E, right? A, C are the prime. The rest of the attributes are non-prime. B, D, E are non-prime attributes. Okay. Now we have to find this relation is in 2NF or not. How to find? This is okay, right? In second normal form, left hand side candidate key, it is okay. Right hand side prime or non-prime, there is no problem. If left hand side is candidate key, then it is in 2NF. Here we will see, is this prime or what is this, friends? This is also non-prime, right? Because here one is prime attribute, one is non-prime attribute. That means it is a non-prime. And here D is a non-prime. Non-prime to non-prime is allowed in BCNF, right? Second normal form. And B comma E. B is a non-prime and E is also non-prime. The non-prime to non-prime is also allowed in 2NF. That's why this relation is in 2NF, because non-prime to non-prime is there into. Okay, one more important point here is to decide whether the given relation is in uh, 2NF or 3NF, whatever it may be, the all the given functional dependencies has to follow the criteria of that functional dependency. Suppose if any of the functional dependency is there in partial, if any of the functional dependency is in partial dependency, then the total relation, we have to say that this is the total is not in 2NF, right? I know, I think you know this. To next we will see one more example here. Here the given relation is VW X Y Z. Okay, what are the functional dependencies? VW implies XY and Y imply Y determines V, WX determine YZ. Okay, please try to solve with me. First of all, we have to find the candidate key, list of candidate keys. Whichever are not present from the relation, right hand side of functional dependencies, X, Y, Z. V, X, Y, Z. V, X, Y, Z is there. W is not there. That means in candidate key, W must be there. In candidate key, W must be there. Now, from only W we cannot get anything, because left hand side single W is not there, right? In previous example, I took one example. Here in this example, AC is there in the left hand side. That's why we find the closure of AC. But here W is not there in the right hand side, but single W is not determining anything. That's why we have to combine other attributes with with W. Already W is there with the combination of VW and WX. Okay, first we will find the closure of the first functional dependency VW. From VW we will get VW. VW is determining XY and Y is determining V, and WX is determining YZ. That means Y is already present here. That's why we took Z. From VW closure, we get all the attributes of the original relation. That means VW is a candidate key. Now we will check WX. What is the closure of WX? WX, we will get WX. WX is determining YZ. Y is determining V, and VW VW is determining XY. Okay, Y is determining V. Yes, all now itself, here itself we got all right. X, Y, V, W, X, Y, Z. Then WX is also candidate key. Is there any chance of any other candidate key here, friends? Here, uh, W, V is there in the right hand side of any VW, is there any right hand side of any functional dependency? No. WX is there in the right hand side of any functional dependency? No. That's why only VW comma WX are the candidate keys of the given relation. If we take Y closure also, we don't get all the attributes because W is not there with Y. Okay. We will try with Y, WY. What is the closure of WY? WY, Y to V, VW to XY, WX to YZ. Here, because V is the right hand side of Y. Yes, yes, friends. Here, please try to understand here. I told VW first we got VW candidate key and WX also we got a candidate key. Okay, W anyway, W is not there on the right hand side, right? That's why only we are combining everything with W. Okay, here is the V is right hand side of any functional dependency? Yes, V is the right hand side of Y. That's why we have to check the WY also. Here we checked the WY closure. We got everything, every attribute from the relation. Then WY also became a candidate key. Is there X? Is there any right hand side of any functional dependency? X is there. We already found VW. We already found WX. That's why WY is also a candidate key for this relation. Then what are the prime attributes? Prime attributes of this relation are V, W, X, Y. Because V is there, W, X, Y. What are non-prime attributes? Z only. Only Z is not there here. That's why now we will check whether the given relation is 2NF or not. Here VW is their left side. VW is a candidate key, right? Then this is a in 2NF. Y is what is Y here? Y is a prime attribute. This is not a candidate key. And here V, what is, sorry, V is candidate key. Here what is V? V is also prime attribute. There is no problem. If right hand side prime is there, then also it is in 2NF. Here the left hand side is candidate key. WX is a candidate key. Then there is no problem. This relation is satisfying all the uh, rules of second normal form. Then we can say that this relation is in 2NF. So relation is in 2NF. See here. I hope you understand this. Please ask me if you have any doubt. Now we will go for 3NF. 3NF means it must be in 2NF, right? If a first of all, a relation should be 1NF, 2NF. If we are checking for 3NF means that the relation must be in 2NF in the first. Must be in 2NF. Transitive dependency of non-prime attribute on any super key must be removed. Okay, there should not be, we have to remove the transitive dependency. A table must be in 3NF if it is in 2NF, and for each functional dependency x to y, at least one of the two conditions hold. what are the conditions we need to check in 3NF? X, if X tends to Y is a functional dependency, X should be super key, or Y, suppose if if it is not following, then Y must be prime. If any one of these condition is satisfied, then the relation, we can say that the relation is in 3NF. Okay, what is BCNF? BCNF is very strict than 3NF. A table is in BCNF means if it is 3NF for every functional dependency X to Y, X must be super key. Right hand side, if we take in 3NF, right hand side prime is allowed in 3NF, right? Is allowed, but in BCNF this is not allowed. Only left hand side super key or candidate key is allowed in 3NF. Okay friends, this is a chart from one of my madam created this chart. This is not created by me. Okay, Priyanka Chatterjee ma'am, she created very nicely this chart. That chart I wrote here because everything is there in one place. First normal form, second normal form, third normal form, BCNF. What is the difference? This chart is clearly explaining whatever I am explaining till now. In this chart, we get everything in one place. See here, the initially the data is in an unnormalized form, right? Next one is first normal form. Okay, what is first normal form? We explained, right? Single value in single cell, value of each column belongs to same domain. This is also very important. We already discussed in the previous sessions the values of the every column. Suppose this is a phone number column, that all should be in integers, right? In the middle, there should not be any character that like that. Next, primary can, in first normal form, primary key can determine all the attributes of the given relation. In second normal form, fully functional dependent on candidate key. Here, non-prime to non-prime is allowed in 2NF. First point is full part of LHS should be candidate key. There should not be any partial dependency. What is partial dependency? Partial dependency means non-prime to prime. Sorry, prime to non-prime. Sorry friends, now partial dependency means prime to non-prime. Part of candidate key is determining the non-prime. Prime to non-prime is not allowed. LHS is not, suppose if LHS is not candidate key, if RHS is prime, then there is no problem in second normal form. If LHS and RHS both are non-prime, it is also no problem in 2NF. Then in 3NF, no transitive dependency should be allowed. If any transitive dependency is there, we have to remove the transitive dependencies. Non-prime to non-prime also not allowed. Non-prime to non-prime is allowed in 2NF, but in 3NF, non-prime to non-prime is not allowed. Prime to non-prime also not allowed in, this is, what is this? This is a partial dependency, right? It is not allowed in 2NF means it is not allowed in 3NF also. Non-prime to non-prime or prime, if right hand side is prime, then it is in no problem in 3NF. Okay, here for each functional dependency, LHS should be candidate key or super key, or RHS is prime attribute. Okay, while finding the candidate key, we should be very careful, because if we miss any candidate key, then we miss some prime attributes, right? Then we will get wrong answer. While finding the candidate keys, we have to be very careful. Okay, next one is BCNF. In BCNF, right hand side prime also, it, it is not allowed. Non-prime to non-prime, it is also not allowed. Partial dependency is also not allowed in BCNF. LHS should be super key or candidate key must be satisfied. RHS prime condition is not allowed in BCNF. because it is very more strict than all other functional dependencies. I hope you understand, friends. Please try to uh, read this and try to, if you don't understand, please try to watch this lesson into speed once more. Then it will be more clear for you. Uh, this is all about normalization. I tried to clear your concept. If you have still any doubt, you can ask me. Please share with your friends also. If anyone is preparing UGC net, please share. If any, at least two to three students is there, it is very good. Please share. If anyone is there who is preparing and he is not attending anywhere, then they can watch here. Okay, here 1NF, 2NF, 3NF, it is very important, friends. Definitions and every normal form, what is allowing and what is not allowed, we have to be very careful. uh, Tomorrow we will solve more gate previous question I brought here also, but tomorrow we will solve the gate previous years question from the normalization uh, and lossy and lossless decomposition also I will explain. Then we will go for transaction and control SQL also. Okay, in this week I will complete DBMS, all the important topics. Okay, please try to watch and please try to be regular in my class. Thank you very much, friends. Thank you for attending the session. Good evening.